Welcome to our review on elastic potential energy. So when we're looking at elastic potential energy, this is the energy we find when we stretch something like elastic or a spring. And the work that we're doing to actually stretch it is being stored in the object as elastic potential energy. Once more, we do have another equation that we need to learn, which is the elastic potential energy in joules is half times the spring constant in newtons per meter times the extension in meters squared. So we can write that in the shorthand form of E with a lowercase e just to the bottom right there is half times k times E squared. To give you an example of the kind of question that could come up on your exam, there's one here. Calculate the elastic potential energy in a slinky which is extended by 5 meters and has a spring constant of 0.5 newtons per meter. As always in our calculation questions, the first thing we need to do is highlight, circle or underline the important bits of information in the question. Second thing to do is write down the equation that we're going to use, which in this case is elastic potential energy is half times the spring constant times the extension squared. Once we've got that, we can now substitute in our values from our question. So half times our spring constant, which is 0.5, times the extension, which is 5, and we've got to square that 5. So plug all those numbers into your calculator, making sure that it is only the 5 that's being squared, and we should get the answer of 6.25 joules. Hopefully at the end of this video we can recall what elastic potential energy is. We can recall the formula that we need to actually calculate the elastic potential energy and use that in calculation questions.